Okay, now we want to talk about our second example of interference, and this is going to be using Newton's rings. So the Newton's rings apparatus is going to be a flat piece of glass like this, and then resting on top of it is going to be another piece of glass. So it's going to come in like this, and it's going to look like that. Okay? Now, the light is going to be coming straight down, and it's going to be reflected, and it's going to go straight back up. But the problem is you can't really illustrate that very well in this picture, because then the lines would be right on top of each other. So in that picture there, it makes it look like the light's coming in like this, and then it's bouncing off, and it's going back up like this. But in fact, it's going down and then straight up. So we've got some light that is going to come in, and it is going to bounce off of this surface right here. And then it's going to go into your eye. Okay, but then you also have some light. So this light here, and this is the color blue, is going to be coming in like this, and it's going to bounce off of this surface here, and then is going to go into your eye like it did before. But notice that where this one has its crest, the other one has its trough. And so this one would be destructive interference. What would it look like? So destructive interference for light is going to be black. You're not going to see anything. So when you look straight down on Newton's rings, you're going to see a circle of black. Now, right next to it, okay, so now let's assume that you have some light that's coming in from here. Let me switch to a different color. So talk amongst yourselves. Okay, there we go. So now we're going to have light that's going to be right next to it, and let's say that it's coming in like this. Okay, now some of it's going to bounce off here and is going to go into your eye, and some of it is going to, again, this is in phase right here, but it's going to go all the way down to here and then bounce and go into your eye. And let's just say, for the sake of argument, that it looks like this. You see the difference? So where this one is cresting, this one's cresting. And so that would be constructive interference. And so what you're going to see is black, bright, of whatever color it is. So this one looks like it's blue. So you're going to see a black ring, a blue ring, a black ring, a blue ring, and so that's areas where it's constructive and then destructive. So what's determining where it's going to be constructive and destructive? Well, it's going to depend on the wavelength of the color of light that you're using. It's also going to depend on the distance between, okay, so the distance between the glass and the glass right there versus the distance between the glass and the glass right there. You see there's a different distance that the light is traveling. Well, does that sound familiar? So again, if we go back to here, it depends on the wavelength of the light, and it also is going to depend something having to do with distance. What about the angle? Well, the angle this time is 0 because it's going straight down and it's going straight back up. So there is no angle involved in this situation. So we're going to call this Newton's rings. Now, what would happen if you use white light? So this was using blue light. What would happen if you use white light? Well, white light is all the different colors of the rainbow. So where one color is going to be destructively taken out, the other colors will be there. And so you'll see a particular color. So what you're going to be seeing is different colored rings, and each of the rings represents where one of the particular colors was removed, but you're seeing all the other colors constructively. And so that is, it's hard to see it, but that's what Newton's rings would look like in white light. You're going to see a rainbow of colors, and then another rainbow of colors, and then another rainbow of colors as a result of it. Okay, so let's take a break, and when we come back, we're going to talk about gasoline floating on water and soap bubbles.